So this is the lecture for tonight, the new material. The situation I share with you will be posted on the agenda for week 3. It's the situation where I took a test at Ohio State in 1983 and I got a 45 on the test out of 100, and I was very, very happy with myself. And then I took a psychology test and I got an 80 out of 100 and was very disappointed with myself. The question I ask you is, how could that be? How could I be so happy with a 45 and so unhappy with an 80? And they were both out of 100 points.
One exceeded your expectation, the other didn't.
One exceeded my expectation and the other did not. That is a correct statement. But anything else? Any reason I must have perceived that I did really well on physics, right? I did. How could that actually be? Have you guys taken physics? It's not how stupid you are. What is it? It's not how stupid you are relative to the 100, but it's how stupid you are compared to everybody else. So, what if I were to tell you that the mean for the psych test was a 90? The class mean, mu, was a 90. I should make these up in a way that's correct. What if I told you the mean for the physics test was a 40? The class mean for the physics test, mu, was a 40. The class mean for the psychology test, 2 of the classes I was taking, was a 90. And I'm sure all the instructors for those classes would be happy to have me be telling the story. How many years later? Many years later. I can't even count. 29 years later, something like that. So does that make a little more sense? Yes, it does. If you want to know where somebody performed, you need to know 2 things. Besides knowing what their score was, you need to know the class average. If you want to know how somebody did, you need to know what the class average is. You need to know one other thing, though. You need to know a measure of dispersion, a measure of variability. Which measure do you think we most often use for dispersion?
Probably average or mean.
Well, is that dispersion, though?
Oh, not dispersion, yeah.
The one we always hear about, it's the standard deviation. So the idea is, in the psychology class, the standard deviation, sigma, was 10. And in the physics test, the standard D, sigma, was 5. So what does this tell us? What would be your idea of what you would want to do? I want to know how I did. What if I told you for the, let's do a kind of prep problem before that one. Let's say that I told you on the physics test that my actual score was a 40. So let's try that example. My score, let's just say my score in the physics, my X, was a 40. Would I still be ecstatic?
It's average.
Would I be ecstatic if I scored average on a physics test? I would be very ecstatic. So I scored. What you were telling me there is that I scored average, right? And that's a true statement. The formula that we use, the one that we need here, the new one. Please, let's keep commentaries to a minimum. It's a new formula. It's called the z-score formula. I put a little line through my z's so they don't look like 2's that much. It's this formula, x minus mu over sigma. This is our new formula. X minus mu over sigma. No, that was a good comment. Way to go. Jeez. X minus mu over sigma. So let's take that second example I just gave you, the 40 situation. what would be the math there? If I scored a 40, what did we just say there?
The average.
That was the average, so mu was 40. What was the standard D for that one? We said it was 5.
Yes, for the physics.
So what would be my z-score if I got a 40?
You take the 5 and you take the 40 and divide it by 5. Right?
Not quite. Nope. You do the numerator first. 40 minus 40 is what? 0. So what's your answer? A z-score of 0 says you scored average. So you've just defined, if you get a z-score, this is called the z-score formula. If you come into my class and you say, Dr. Tausman, I took this class last semester, and on the first test, my z-score was 0. Would I be upset with you? No, I would know that your score was average. Statistics, not that far away from physics for some. A z-score of 0 means you scored average. If you turn to page 141, in figure 5.13, you can see they have mu there. Mu, if you score at mu, that's a z-score of 0. So the z-score thing is just a transformation. Let's try these other situations. So let's take the 45 example. The 45 example. So if I got a 45 and I was ecstatic, what would be my z-score? You got a value of 1. Did you do? What would be the math there? 45 minus 40 over 5. So 45 minus 40 is 5. 5 over 5 is plus 1. Make sure you have the sign on these. Sign matters. Plus 1. You got a score of plus 1. Is that good? Yeah, that means you did better than average. We'll go into how much better a little bit from now. Let's do the psych exam. The psych exam. What would be the score for the psych exam? A little math, but not much. What'd you get? Did you get negative 1?
Mm-hmm.
What'd you do?
Well, it took 8. All right, the score was 80.
Yep.
And I subtracted the average of 90.
That's right.
Okay.
Divided by, yeah.
Divided by 10.
Yep.
Oh, it is 1.
Boom, there it is.
I got it.
Don't
All right,
worry.
sorry.
Shakespeare said self-knowledge is the key to redemption.
I'm like, oh yeah, okay.
Negative 1. So which class did I do better in? The psychology class or the physics class? Physics, because a score of plus 1 is much better than a score of negative 1.
Gotcha.
So z-scores are our way of figuring that out. Z-scores are our way of figuring that kind of stuff out. And we like them. Are you kind of following along?
Yes.
Works out okay? Let's actually take it to one more level. What have we got here? 8 minutes. Let's ask you this question. In the physics class, I got to think a little quicker here. No, this will work. In the physics class, my score was 45. Would I rather a situation, so you can write down for this example, my score was a 45. Actually, let's make it easier. Let's say my score was a 50. Let's say in the physics class, my score was a 50. The class mean was a 40. The question I have for you is, would I rather be in a situation where the standard deviation was 5 or 10? Would I rather be in a situation where the standard deviation was 5 or 10, given the 50 and the 40? So you can write that down. Would I rather have, for me personally, an SD or a sigma, a 5 or 10 there? These are the kind of the thought questions you'll get next week. Which would be better? And it's okay to share and have the wrong answer here, and then we'll figure it out.
The 5?
You would say it would be better to have the 5, the standard deviation, than the 10. What would be your logic there?
I gave you a +2,
Yeah.
and the other was a +1.
The other was a +1. Why would it be? So a +2 would be a better score. If the standard deviation was 5, then my score of 50 would be a +2. If the standard deviation was a 10, my score would only be a +1. It's the higher the score, the better. And a negative score is worse, and a 0 is right in the middle. And think about that even from just a thought process. If the standard D is 10, that means that if the class mean was, what did we say here, 40, that means there were a few people who kind of got around 50. But if the standard deviation is 5, that makes me more extreme. And more extreme in a positive way is good. The logic is just the opposite on the negative side. If I got a 30, I would hope that the standard deviation would be 10 and not 5, because I'd rather get a score of -1 than -2. Because -2 means you really stunk it up compared to everybody else, because they're all kind of clustered around the mean, and you were really extremely negative, as it would be. Sorry, another case came to mind. When I was doing my rehab, I'll share. Oh, wait.